Hello, everyone. Today we are going to talk about the things that you need to know when you solve a planar truss or a 2D truss. Even though you know that this is a bridge, it is a 3D, but we can actually um, consider it as a 2D and analyze the structure and find out what are the beam, what are the member forces in each of these truss member. Okay. So when you come to when you join a structural analysis class or a static class, like you get excited about taking the classes, and then you will see that this 3D cross bridges can be idealized or simplified as a 2D, and you'll see that this is a pin and this is a roller, and then we have all the member um, connected, and then like, okay, good. I have drawn the cross structure. Now I want to analyze and find what are the force member of the truss under the given load. Let's say that the load is applied here, and you are excited to learn about truss analysis, but you then you get into a problem. Like you find it difficult, like where to start, how to start, like how do I know the value, uh, and everyone is getting different answer than what I'm getting. Why? And you'll be wondering why that's happened, and then you're trying to solve it. You try to look at your equation. It's like everything doing it correctly, but why our result is different, or why is it wrong? So today I'm going to show you the things you need to know when you analyze a structure, especially like this kind of a structure, because um, uh, there are some requirement that you must know when you analyze the planar truss. Okay, so that's what I'm going to talk today in this video. So what are those things that you need to learn when you trying to analyze a truss, especially in your static course, structure analysis, or even if you're preparing for your FE. So the first one is determinacy. Determinacy, it means that whether you can determine all the unknown forces in your truss using equilibrium equation. Okay, so that is what determinacy is, and whether the structure is stable or not. That's what determinacy means. And then second is finding the zero force member. If you fail to identify the zero force member, then all your force member will be wrong, because if you have to meet the equilibrium equation, then if you don't identify the zero force member, then you will incorrectly put those member that are zero as some value, and you'll get the whole equation wrong. And then what you'll end up is you'll end up having two different answer for one member, which is a violation, because you cannot have two different forces value for one member. One member should have only one value, and one member should have only one type of force. But um, under specific loading, if you're getting two solution or two value for the same member, that means it's not equilibrium. So that means you're doing something wrong, and the reason is because you did not identify the zero force member. And then third one is sign convention. We always follow the positive means tension and compression means negative. If you indirectly use the wrong sign convention, then you'll get a wrong value again. If it is compression and you put positive, then you are making a mistake in your calculation. And then drawing the free body diagram. Again, this drawing the free body diagram is very important in engineering, because it helps you to understand how the force reacted, or what are the force acted on each beam or each truss. So drawing the free body diagram tie very well with knowing the sign convention. Without knowing the sign convention, then drawing the free body diagram will make, and then you make a mistake if you are not sure what the sign convention is. And then trigonometry and resolving force. I mean, sometimes students consider x as cos theta and y component as sine theta, but but if you take the angle differently, then you will resolve it incorrectly. So that's what I'm going to take. And then there are two methods to solve the truss analysis, and which method works best or which method you should use depends on the requirement. So I'm going to discuss that. in this video. So the first thing that we need to know is determinacy. What does determinacy means? Determinacy, it has this equation. It says that the number of member forces plus unknown support reaction is equal to the number of joint. And we know that in a truss at a joint, we have two equilibrium equation, which is uh, summation of all the forces in x direction and summation of all the forces in y direction. So this become 2j. So number of member, because member are unknown, these are unknown, and these also are unknown, and this is a known equations. So if the number of unknown is equal to number of known equation, then we call it as determinate structure. So what are these m? M is your number of members, and r is number of unknown support reactions, and then j is number of joints. So if these are equal, then we call it determinate. If m plus r is greater than 2j, then we say that it is indeterminate. So which means that you cannot use this equation to solve your unknown numbers. So you will need plus boundary condition. So you'll need to add additional equations or initial conditions. You need to know the either the boundary condition or initial condition to solve all the unknown uh, forces in indeterminate structure. So if it is equal, then equilibrium equation will be enough to solve all the unknown forces. And if it is greater, then it will be indeterminate structure. And if m plus r is less than 2j, then we say that it is unstable, which means that not enough support to resist the load. Okay, so if there's not enough support to resist the load, then it is unstable. So more about unstable and how to find unstability. Unstable, you will find in any textbook in structural analysis or in static. So so for this one example, how we have m, we have r, and we have j, and we have 2j. So in this case, if we draw all the direction of the support reaction, we know that if this is A, we call this as AY in Y direction, and this is your global axis, X and Y, and this is your um, X, A, X. And then let's say that this is B, so we know that this is a roller support, it has only one um, unknown support. This is pin, it has two reaction, and roller has only one. So let's calculate it. So this is 1, this is 2, this is 3. So we have 3r, and then this is m1, 2, 3, 4, 5. So we have 5 member. So if you plus them together, you get 8. And now we calculate for the joint. We have 1 joint, 2 joint, 3 joint, and 4 joint. And joints means it's a joint that connected them, it's the end of the member. Okay, so joint is the end of the member. So this member has 2 joint. So we have 1 joint, 2 joint, 3 joint, 4 joint. So in a total stress, we have 4 joint. And you'll see that this is A. So that means this is determinate structure. So which means that Using only the equilibrium equation, I can find all my unknown forces. And what does it mean? I can find this, I can find ax, I can find by. If you apply a load, let's say you're applying load p, I can find ax, ay, by. I can find this member forces, this member forces, this member forces, this member forces, and this member forces. So all the member forces plus the support reaction I can find just using the equilibrium equation. And because I'm solving for the whole truss, I'm not at the joint, so I can use fx equal to summation of all the fx equal to 0, summation of fy is equal to 0, and summation of moment is equal to 0. If I have to solve only at the joint, then I can have only two equations. But if I have to solve for the whole structure, then as a whole structure, then I can use all these three equilibrium equation. Okay, so that's the how that's the first thing is determinant. Most of the question in the exam, especially unless it's specified to find the determinacy, if you're asked find the member forces, like find the unknown member forces of this truss, which means that it is already by default it is a determinate structure. So most of the time we don't worry too much about determinacy unless you were asked in the question find the determinacy of the truss, then you will use this equation. But if the question itself say that, hey, find the unknown forces, that means uh, you don't have to check for determinacy, because it is by default it is a determinate structure, which means that using your equilibrium equation is enough. So that's the things that you need to know about analyzing a planar truss or a 2D truss